What we're going to do now is learn how to sketch a polynomial in any form by factoring completely and finding all the roots, type, and y-intercept. Now, of course, most of it's pretty easy. We already have the type here. This is odd positive, which we mean is going to start negative and positive. We also know the y-intercept, because if x equals 0, y equals -6. So we got 0, -6. All we have to do now is find the roots. Now to find the roots, we must factor it. Now how do we factor this one? Oh no, we can't. What we have to do is our p over q, plus or minus p over q's. So we know p is 6, so its factors are going to be 1, 2, 3, and 6. Q is 1, so we get 1. So my possibilities are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And remember, we only have to find 1 to make this work. Okay? Using my P&I chart, if I make these negative, 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 I know there's going to be no negatives if I use my Descartes' law of signs. So I don't have to check my negatives here. Positives, okay, so I'll check 1, see if 1 works. I go 1, -6, 11, -6. Check it. 1, 1, -5, -5. 6, 6, 0. So I have 1, 0 equals 1. Now there are 3 of them, don't forget. So I find the other 2, not by plugging it in, not by my rational root theorem, but by factoring, because this is now was x cubed, it reduces to x squared. And I can factor this one, x minus 3, x minus 2 equals 0, so I get 3 and 2. Now I have my zeros. Well, how does that help me graph this? Well, I just found my zeros. Whoops, that should be a 2, not a 3. So I got 1, 2, 3. And here's 0. So if I make 0 my y-intercept here, right? It crosses at, down here at -6. Down here, crosses at 1, 2, and 3. And because I know it's odd positive, it starts negative, ends positive. And it's just going to go cross, cross, and up. And we have what our graph looks like. After much debate with myself, we have found that number 2, there's an error in there somewhere. None of them turn out to be rational, so let's not worry about number 2. Let's take a look at number 3 instead. Now for number 3, it's the same idea as number 1. We're going to get the type. Hey baby, what's your type? That's easy enough to do. Look here, it's odd positive. So it starts down, ends up. It's y-intercept. Again, if we let x equal 0, y equals 0, 0, 0, 35. So we get the point 0, 35 right here. And now to get the roots, we need to factor this. But unfortunately, it's just not easy to factor. So what we're going to do instead, we're going to use our p over q's. So my p comes from 35, which is 1, 5. The factors 1, 5, 7, 35. Our q is the 1, which is just 1. So our possibilities are plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 35. And now we have to guess and check which one's going to work. Now, if I check 1, I try 1. Whoops, sorry, messed up. If I try 1, messed up again. Wow, I'm on fire. I plug it in. 1, 9, 27, 35. I get 1, 1, 10, 11, 38, 38, that's definitely not going to be 0, so 1 does not work. Now one way, if you remember, I can eliminate is using my Descartes' law of signs. These are all positives, so therefore I know none of my positive roots will work. So I'm going to start with my negatives. Now after I have done this one already, so I'll just go and tell you which one is going to work. -5 works. So we go 1, 9, 27, 35. Get 1, -5, 4, 20 becomes -20, sorry, becomes 7, and we get negative 35, and we get 0. So for our roots, we're going to have 3 of them, x, x, x. We get negative 5, and then the other 2 roots, we're going to have to solve this one. X squared, our reduced polynomial, plus 4x plus 7 equals 0. Now we can't factor it, so we do have to use our quadratic formula. X equals negative b plus or minus the square root 16 minus 4ac all over 2, just 2. Now if you notice for this one, we have imaginary roots. So we get x equals negative 4 plus or minus the square root of, that's 16 minus 28, so negative 12 over 2. So we don't like that negative 12, so we should remember how to write this. Negative 4 plus or minus I root 12 over 2. So we get negative 4 plus I root 12 over 2 and negative 4 minus I root 12 over 2. And so now we're asked, of course, to sketch this graph. The only real root that we have is negative 5. And I'll put my y-intercept over here. There's my y-axis. It does cross here at 35. And it starts down in positive. So when I graph it, it's going to go through the 5. Now, people always ask, how does the imaginary affect the graph? Well, we don't know that quite yet. We need calculus to graph it. But because I know it's cubic, I know at some place it's going to have to bend. So I might bend it at the 25 over there. And that's kind of what our graph will look like. All right, we're going to take a look at a few more of these tomorrow in class, so make sure you look them over. Okay, we'll see you then.